last year I did a lightning talk at Baisu on a similar topic. I think the title then was something like building artificial moral progress into AI systems. And yeah, today I'm sharing like some like more concrete follow-up stuff on that proposal. Yeah, first I'll try to share the frame that I myself have converged upon after a year of working on that, and also sharing like an experimental framework that I and my collaborators have been developing over the past year, which can hopefully be very useful for like later research on this topic. Cool. So yeah, as the topic suggests, the thing we'll be introducing is called ProgressAlign, and the aim of it is to like advance research on what we call progress alignments, which aims to like align AI systems with the millennium of moral progress that we have observed. Cool. And first, a bit about myself. I'm an intern at the Center for Human Compatible AI. I'm personally working on emulating moral progress in alignment algorithms in order to prevent premature value locking. And in my opinion, this problem is similar in scale to other X risks from AI. It itself is one X risk from AI under the definition of like X risk being a risk of losing a significant portion about potential long-term impact. Under that definition, I think value locking is an event that counts as existential risk. And I also think it's probably more urgent, given that it may not require rather advanced AI capabilities, and also I think unbelievably neglected given its scale. I'm especially interested in ways to leverage the power of like more mainstream academic research communities, similar to what Dan Hendricks called pragmatic AI safety. So that means I will try to adopt approach which includes both research and field building. And yeah, like I previously co-led the writing of AI alignment, the comprehensive surveys. So that was a survey article like featuring the both the short-term aspects and the aspects of the alignment research. Yeah, so into our main topic. We know that large language models and also other frontier AI systems have been used in a lot of cases in our society. So this includes serving as a personal assistant to answer all our questions, and also of flooding the internet with machine-generated text. And also in like some of the more critical or more sensitive areas, for example, K-12 education. So language models have been used to like generate plans for teaching, or to shape class discussions, and also grade essays in state level exams. And we can so there are also signs that AI systems based on language models can make important decisions in business, social, or policy settings. Um, this may not have been like very widespread currently, but there seems to be a lot of potential in that space. Yeah, we have talked about a lot of these current and potential applications of large language models and other frontier AI systems. So a natural question to ask is what could go wrong in those applications? So we know that the applications we have previously enumerated, they all share one commonality, which is that they exert some kind of influence over its human users. That this is most salient in the K-12 education case, where of course K-12 education have a lot of impact on the students' views about everything. So yeah, what we want to claim here is that the behaviors of AI systems have increasing influence over our beliefs, values, and possibly even the running of our society if those decision-making applications get realized in the future. Yeah, so one thing to ask is that the values or tendency to display the tendency to act according to certain values. These traits in LMs may have the potential to influence the human users. Um, while it's debatable whether there are like explicit representations of values in language models, we can all agree that by training them in different ways or by training them using different data, we can make these models display different types of behaviors that are in line with different values. So there's this piece of research where the researchers have found that human subjects co-writing with an opinionated language model will tend to prove their opinion towards that language model's opinion, and the effect is not insignificant. So, so in the diagram below, we see that there's like something like 15% difference between working with the language model with a positive opinion versus working with one that has a negative opinion. And this suggests that the moral tendencies present in the model's behaviors can influence the values held by the potentially vast number of human users that are interacting with them. And we know that the training data of language models are sourced from the internet and also other like human-generated sources. This means that these data are subject to contemporary biases and misconceptions. So what we do not know and what we get wrong, the language models themselves were probably not able to get them right. Therefore, this means that these systems may learn and perpetuate these contemporary biases and misconceptions in the deployment and interaction with humans. And we can take this possibility to extreme. So suppose that these AI systems are widely deployed in society, and they learn the current values really well and act upon them perfectly. We can imagine that this could lead to a societal scale entrenchment of these potentially biased values and beliefs, which is a phenomenon that we have called value locking. This locking event, first, it risks perpetuating existing problematic moral practices. And what's more important, we ourselves currently are probably subject to a lot of moral blind spots. Uh, just like how people for centuries ago may have more blind spots of slavery. So if we have these more blind spots, as these the language models that are trained upon the data that we generate, these models are probably subject to the same blind spots, and we cannot hope that they will help us correct them. And despite its seemingly large-scale impact, it's still very under research right now. So in Dan Hendricks' post on the alignment forum, he had described one research area, which is basically figuring out what values we should take by using AI, like doing the moral philosophy to figure that out. So he calls it, I think something like value clarification. And when describing who's working on this problem, he says, quotes, nobody. And yeah, that tells a lot. So we have talked a lot about this problem and what could be some solutions here. We know that historically, the main driver that pushes against this value locking had been human moral progress, which is the societal improvements in moral beliefs and practices. A perfect example of that would be the abolition of slavery. So this leads us to wonder whether we could emulate moral progress in the alignment procedures of AI systems, which means that we want these we want our alignment algorithms to learn the universal mechanisms driving this moral progress, and then replicate this mechanism in the operations of the AI systems. So, in so what basically we're imagining taking an alignment algorithm and take this mechanism of moral progress, and we put them together and produce something that aligns the models in a way that allow them to improve over time, similar to how we humans have improved in the past. So yeah, this sounds really cool, but is this even technically tractable? I think it is, and I'll try to explain why I think so in the um, next 10 or 20 minutes. So yeah, well, first we are going to give a problem formulation for this moral progress stuff, and we will model it as a partially observable MDP. So if you don't know what the MDP is, like a 1 minute description would be that imagine a world that could be many different states. So for example, let's define the world to be the yeah just whatever the values are inside the human's brain, and that could be a wide spectrum of values, and these different possibilities of values become the collection of states that the world could be in. And then we imagine that the AI agents will do some interaction with the human, which will result in some kind of value change in the human agent. And that forms a kind of state transition for the world state, which means that the human value change from one state to another due to this interaction with the AI agent. And by this partially observable MDP thing, we are saying that first, we don't have the AI agent does not have perfect information on what the world state is, or like what's the values inside the human's mind. The AI can only get observations in the form of human generated text or something. And second, um, in this process, the AI agent will like continually interact with the humans, following some kind of policy, with the end goal being to, in some sense, advance moral progress throughout the process. So we are explain this part by part. First, we define like the collection of the hidden states. So any hidden states correspond to a possibility of human values. And then we assume that the AI agents can gain imperfect observations on the hidden states. So in the case of the most classical alignment algorithms, these observations can be like human indicating that they prefer one response over the other, which is what we call human preference annotation data. And also we assume that the AI agents can exert influence on the hidden states, aka on the human values, by taking actions. So the AI agent can decide, okay, at this point in time, how should I interact with the human in order to inform its values? So maybe I should like tell the human what is the spectrum of different views on this problem out there, and let the human decide what would be better upon reflection, for example. Okay, and yeah, the AI agent's action space, which is the space of different interactions it can choose from at each time step. So this action space, we define it to be the space of possible values for the AI to choose from. So for example, if the AI choose to be like a very balanced assistant, which just tell the human all the spectrum of different views, then that would be one potential set of values to choose from. And the action space consists of all these different potential choices. And finally, the AI agent's reward function this is the thing that the AI will optimize for throughout this process. This reward function needs to be some measure of moral progress that is induced by the AI systems in this human AI system. So this is to say, like in this long iterations of interactions, the ultimate objective of the AI agent is to advance progress in the human AI value system. And this leads to the question of how can we measure this moral progress thing. And we will touch on that later. So let's reflect on what we currently have and what's still missing. We already have a formalism of this moral progress thing, but we don't yet have, first, we don't have actual instances of these partially observable MDPs. So there is not such a program that can just simulate this partially observable these pure MDPs for me. And this means that I'll not be able to develop and test algorithms using this partially observable MDP formalism. And also, even if we have these simulated environments, we still don't have those reward functions that we have talked about. So these measures of progress that should be the ultimate objective of the AI agents, we still need to define them. This leads to a situation that seems quite familiar to perhaps some of the audience members. This is really like what early stage reinforcement learning research look like. So we have formalism, we have like proposals for algorithms, we have some scattered methods for testing them, but there is not a standard interface. There are not a standard set of tasks, which make it hard to like test the algorithms developed and to compare the results. So recall that in reinforcement learning, this problem is eventually solved by OpenAI. This is a platform that allows the creation of a variety of different RL environments. And this has proved to be very important in the development of our research. So here, for us who are interested in progress alignment, we need something similar to this OpenAI, but built for progress alignment instead. And by building progress gene, I'm hoping to like do this thing here to provide a platform where later research can build upon. So first, it is an experimental framework for this progress alignment problem. The aim is to allow learning universal mechanics of moral progress from human history. And more concretely, it is first built upon 9 centuries of historical text data. So the justification here is like the historical human values are reflected in the historical text data. And by modeling these text data, we can see how human values have historically changed over time. And this should enable us to learn the pattern or the mechanics driving that change, which will in turn enable us to build progress alignments. And based on these 9 centuries of historical texts, we have fine-tuned 18 historical language models at sizes of 8 billion and 70 billion parameters each. So the reason for fine-tuning these models is that by having these like historical language models, we are basically able to chat with the simulated person from a past century. So we have like 2 models for every past century starting from the 13th. So that means we can, for example, do reinforcement learning from human feedback using feedback from a 13th century person. In that way, we are able to like align a language model with the 13th century values. And then by comparing the language model that is aligned with different centuries, we can do some useful analysis. But that's not the key point here. The key point is these 9 centuries of text and 18 historical models, they serve as the data sources for progress alignment algorithms. And using these data, we can then develop concrete benchmarks for progress alignment. And once we start trying to formulate this benchmark, we realize that there are a lot of degrees of freedom out there. There's just not one single way to define that can be agreed upon by everyone. So instead, we can only try to identify different specific challenges within the progress alignment problem and formulate them each into their own benchmarks. And this is what the progress stream environment allows. So for example, we have as a starting point, we have identified and implemented 3 key challenges into benchmarks. So the first one is what we call follow, which is like when the human population when their values change over time, we need to implement a lifelong alignment algorithm that always keeps up with their values. And in this task, in this follow task, we want to evaluate how well this tracking thing is done. Like, what is the latency between the human values and the machine values, which is lagging a bit behind the humans. And the second challenge that we implement is what we call predict, which is that if we only like try to follow the change of human values, we will not be able to overcome the current human moral blind spots, which have been our primary motivation for doing this all along. That means we need to somehow look ahead of time to preemptively anticipate more progress. And however that is done, we will need some kind of prediction capabilities. So for example, we'll be able to like look 10 years ahead or like 1 year ahead into what human values could be after that period of time. And we don't need to do that like with 100% accuracy. That would be perhaps near impossible to do. But instead, we are aim to achieve a consistent track record for like anticipating this progress over the 9 centuries of data that we can test upon. And finally, there's this co-evolve task, which perhaps is the most interesting of the 3. So when motivating this project, we have talked about like the feedback loop between the human values and the AI values. We know that the AI values are like sourced from the human data, which means that the human values naturally feeds into the AI values. But the reverse is also true, since as we talked before, the AI have been influencing our values and will be influencing our values more in the future. So this two-way influence means that there could be some like very peculiar dynamics between the two. And we definitely don't want this dynamics to be one of stagnation or like pulling behind, but rather be one one that is consistent with the moral progress that we have historically observed and are hoping to replicate in the future. So concretely speaking, this co-evolve task, it measures the extent to which this feedback loop leads to moral backwardness as opposed to forwardness. And this backwardness and forwardness is measured by calculating similarities of resulting values with different points of values in history. Okay, and once we have these different benchmarks or different challenges, we can then develop algorithms to try tackle them. And again, as starting points, we have implemented two example initial algorithms. So the first one is what we call lifelong methods, which are rather simple. We just take any existing alignment algorithms, for example, RTREF, and then we iteratively apply it on the model. So for example, we do it once every year or once every 2 years. And hopefully this will mean the model will be like aligned with the human values near real time. This could like minimize the latency between the human values and the AI values. But of course, it may not be able to look in the future. It might perform very, very bad on the predict and co-evolve tasks. So in order to overcome that, we can instead propose this extrapolated alignment methods, whose idea is that we do not just follow or like update the model towards the current set of human values, but instead we keep track of a history of different versions of models or different versions of human feedback data. And once we are able to transform them into numerical representations, we can do some kind of extrapolation on this time series to like extrapolate it one step ahead, and instead use that extrapolated result as the objective of alignment. So we have like initial implementations for these two types of methods, but we have not comprehensively tested their performance on the benchmark. So unfortunately, I'm not able to report their performance here. Yeah, and as I said before, these are only starting points, and I expect there to be a lot of other challenges and way better algorithms than the two listed here. Yeah, I realized I haven't like paused to see if there are questions. So yeah, feel free to ask anything if there are things on your mind. Cool, I'll continue then. Uh, yeah, and then let's take a closer look at what this framework actually looks like. So on the left, we have this basic abstractions, which are like three interfaces for models, data sets, and data collections. So this is the interface that the historical text data sets and the historical models will be used in the framework. And then there are in the middle, there are these two judge-based and examinee-based classes. So these are the templates that you need to fill in order to create a challenge or to create an algorithm. And we have like we just said, we have implemented three challenges as starting points, and they are implemented as classes that inherit from those base classes. So we have follow judge, predict judge, and co-evolve judge. And likewise, we have lifelong algorithms and extrapolated algorithms as classes inheriting the examinee-based class. Yeah, so we have finished talking about how this experimental framework look like. And finally, we can try to see what could be some like future directions for research on progress alignment. As mentioned before, we are formulating progress alignment as a partially observable NDP problem, which means that we can decompose the problem like we decompose any such POMDP. So here we can tear it up into 4 parts. First, there's value data collection, which is how we get these observations of human values. So Currently, the way to do this is to like ask questions on humans, like given these two responses, what is the one that you prefer? And if we observe that the human subjects consistently prefer responses showing one kind of value as opposed to another, then we can conclude that the human tends towards the former type of value as opposed to the latter. And this is certainly rather costly, which is partly why these human preference data sets seldom go higher than like 100,000 comparisons. And instead, another way to do this is to use unstructured data. So raw internet text and possibly the images, video data on the internet. This would have the advantage of like very huge quantities. It would be larger than the structured preference annotations by many orders of magnitude. And it will contain a much higher abundance of information because you include the other modalities, the images, the videos, other than only text conversations. So yeah, one open question here is how we can move from these structured data into these unstructured data. And then there's the problem of modeling value dynamics. So when we decide how the AI should act at a certain time step, we need to be able to have a sense of what will be the consequence if the AI acts in that way. That would mean we need to do some kind of modeling on the dynamics of this feedback loop between the human values and the AI values. So of course we can do statistical modeling as we deal with many of different time series, but there also can be possibilities of realistic simulations of the like social dynamics involved in the process, which have received some research in social science areas, but have not been much of focus in the ML community to date, I think. And the third part is how we make the choice of like what value we should embed into AI systems. So this is the part where there are many different ways to do this. We can certainly do some simple rule-based heuristics. For example, we just extrapolate one step ahead and always adhere to that extrapolated result. Or we can do reinforcement learning. We just do like learn a policy of value choice using using trial and error learning. And then there are also control theory, and game theory and social choice theory. The latter which deals with how we can aggregate human preferences in a population of very diverse opinions. And finally, there's the problem of implementation. So if we have decided a set of values to embed into AI systems, how do we actually do this embedding? Most methods currently use tuning-based approaches to do that. So you have a data set of like texts or conversations that display this kind of value. And then you fine-tune the language model on that data set. Or instead, you use a like somewhat more complicated pipeline where you first train a reward model on that data set. And then you use the reward model, which serves as a human proxy, use that model to provide signals to tune the language model. But this is certainly not the whole story here. There are also many different other ways to do this implementation thing. One would be scaffolding. So we do not change the underlying model. We just change the program that calls this model. So imagine pipeline where the model generates some response, and then the response is refined through using some kind of refinement pipelines. And you can adjust parameters in that refinement process in order to like steer the generation results. And also perhaps more unexplored are the developmental approaches and the mechanism design approaches. So the former refers to approaches that try to steer the process of training the model from beginning to end. So the aim is to like have the eventual model adhere to some kind of rule sets or values, and make sure that this adherence is robust in that it is like embedded deep into the model rather than only superficially. This perhaps can be done through developmental approaches. That is, you steer the entire training process of the model. And the mechanism design thing, like, focuses on how we build the like human AI interaction environment. So how do we set the rules for interactions and design the mechanism for interactions in order to like facilitate this value implementation? Um, yeah, so I've enumerated these many different ways of doing this in a rapid fire manner. So most of these are still very underexplored or even like underspecified. And I expect that there could be like a huge space for deconfusion and like more concrete algorithmic research. Yeah, and finally, I think there's a problem to address, which is like mm, what is the principle upon which we decide this value stuff? So the things we have been talking about, like the implementation of a set of values into an AI systems, they sound a lot like dictatorship. Like, who are we, or why do we have the right to decide these values in AI? Yeah, I think that's a very good question, and I think this means that whatever approach that we take, we need to be very careful. First, it had better to be a method that allows humans in the loop, so that if the algorithm itself doesn't work as we expect, we'd be able to like correct it promptly once we spot the problems. And second, the whatever approach that we take, it needs to be value neutral. So ideally, this method should not like hard code any kind of set of values that we prefer, but rather it should, for example, crowdsource the values from a demographically representative sample of human population, something like that. And yeah, I think these two principles need to be taken very seriously. Yeah, and that is the end of the presentation part of this session. So the progress stream framework that we have been talking about will be open sourced around the end of May, and will probably also be available as a PyPro package plus a web interface. And questions welcomed, and also feel free to get in touch via these links.